Hello everyone, this is part 2 to my video of simplifying and solving logarithmic equations and expressions and all that. In my part 1 video, we really covered this part. We simplified, everything that we had from easy to a little bit more complex and longer. We did that, and I think you got the hang of it. You just need to do more practicing, and if you feel uncomfortable, of course, just do a little more practicing and you will get on it. In this video, we're really gonna cover this topic. We're gonna solve log equations, right? So before I give you examples, I'm just gonna write one rule of changing a basic log to an exponential. Let's have a look. Okay, so let's start with my example. So let's say I give you log base 5 2x minus 1 equals 2. Okay, so there are two things you can do. I'm going to teach you two of the methods you can use to solve this or any other harder maybe problems. You can use this rule, changing this function into exponential form. Okay, you can do that, and we will quickly do that, and then I'll show you another way. So if we do that, we get the base. The base is the base of the log, which is 5, and then the y is your answer, equals this. I don't really need the brackets, okay. And if we do solve this, we get 25 2x minus 1. If we bring the 1 over, we get 26 equals 2x divided by 2, both sides, and you will get x equaling 13. Okay, great. Now another way, see, you gotta think about logs. Logs, you gotta think what cancels a log, because we really want to get rid of this log. We want clean numbers. What do we need to do? We need to solve for x, right? We don't want a log. What's the inverse of a log? What's exponents, right? So we really have to make this an exponent to raise it. There has to be some base, so this can be an exponent. So the log and the exponent can kind of cancel out. Okay, I know that's confusing, but whatever you make the base here, you have to make the base here. So the 2 will also be something to the second power. Okay? So, but what is this number? Well, this number is always going to be the base of your log. So in this case, 5. And if it's a 5 here, it has to be a 5 there. Now, what happens? Why did we do that? What's the point? Well, we want to cancel log. Since now we have an exponential base, which is the same as your log base, they cancel. The base of your log and the base of your exponential, they're the same, they cancel each other. Okay, so we are left with this and 5 squared, which is the same thing, it's just on a different side. So if we also do that, 26, 2x divided by 2, and you get x equaling 13. So, same answers. Now, I need to tell you one thing though. When you solve for x, or you have two solutions, or however much solutions, if you have a solution that you think will work for x, you solved it, you need to make sure that when you plug it in, when you plug 13 for x, you don't end up with a negative number. So obviously, we will not get a negative number, because 2 times 13 is 26, minus 1 is 25. So since 25 is a positive number, you're good. So this is the right answer. Next example. So in my next example, I'll maybe stick with this method because for some reason I'm used to this method. But No, actually, I'll use this one too for the next one, and then we'll see what happens after. Next one is log base 3 x minus log base 3 of 4 equaling 2. Okay? Now we have two log functions here, two log, pieces. We want to change it into one log. Now, if you know your rule, subtracting your quotient property, we can put it under a ratio, under a fraction, because you're subtracting. That's one of the, if you have the same base, which we do, that's one of the properties. This thing over this thing. 1, 2. And now if you do it the way of changing this to exponential form, you will get 3 squared equaling x over 4. Or if you do it the way I showed you, you have to raise this side and this side to some value. The value is going to be this base. In order for them to cancel out, whatever you raise here, you have to do the same thing. So you're gone with it. You're gone. These things are gone, and you're left with x over 4 equaling 3 squared. Same thing. And if you continue, multiply by 4, 9 times 4, 9 times 4, and x will be 36, 9 times 4, these guys cancel, so you get 36x. Oh, this is atrocious. Okay, so that's basically, okay, now we have to check though. If we plug this in, if we plug it in, we will not get a negative number. That's your basic point. I mean, the best way to do it is what did I want to say? Is to actually do it left side, right side check. But at most you have to at least see that. You can just glance at it and see if it's not a negative number. That's good. Okay. Example 3. It's going to be 2 log base. We don't know the base number here, okay, but it's okay. We're not given sorry. No. It should be x minus 1. Okay, that's it. Alright, quickly, let's do this. So, we got 2 logs here. We want to make it into 1 log at least. So, it's going to be something log. We want 1 log with the same base. So, it's going to be base. And something here. But hold on. Here, because we have this 2 in front, I don't want that. I want to put it back in its place. We're really doing the reverse exponent property. So, it's going to be log, sorry for the noise by the way, x squared, right? And here, since we want to put them together, adding, it's your product property, adding 2 logs with the same base, same thing as multiplying them. So, you get 4x minus 1. And if we just finish this off, you get log base b, distribute. Okay, now you have to use a different, you can't really, I mean you can, but it's just so much work. The best way to do this is to either raise it as an exponent to some base where this log will cancel the base of the exponent, so you will have this and that. Or you can do this. Notice the fact that you got the same bases here. You got a b here and a b here. So when you have 2 same bases, you can let these guys equal each other. Right? Hopefully you understand what I said. Minus 4x plus 4. Okay? But if you do it the way I just said, my first way that I was talking about, you raise it to the same to the same base of your log. So you raise it to the b. No, oops. So this really, you know, like that. These guys cancel, because these are the same. These guys cancel, you're left with this and this. Okay. Now, luckily, this is factorable. This turns out to be x minus 2 and x, minus 2. 0 or x minus 2 squared, you have two same things. And this will be x equals 2. Now you need to check. If you plug in a 2 into your function, will you get anything negative? Let's see. If you plug in a 2 here, well, you're good, right? Nothing's wrong with that. This one, no, we can't really plug in anything. Here, if you plug in a 2, 2 minus 1 is 1. So 1 is perfectly fine. This is the right answer. Now let's do my fourth example. Okay. Fourth example. Natural log. I'm going to work with natural logs this time, but they're the same thing, just very similar. So the third. To the fifth. Okay. Alright, so let's observe. First of all, the natural log, just want to point out to you. The natural log is just log with a base of e. E is called Euler's number. See, when I was introduced to this e, because e is just a special number. When I was introduced to it, I would never say Euler. I mean, I can never say that's Euler. I would say Euler. Until a professor told me that's not right. But it's still hard for me to continue, you know, saying Euler. I don't know. It's just, I'm probably the only one who would encounter such a funny story. But yeah. So it's kind of weird. Anyway, so that's what natural log is. It's just log with a base of e. But we don't really need to know this right now. I just wanted to point out to you what natural log is. Hopefully you know already. Okay, I'm just gonna move on here. See, we can apply the same properties apply to natural logs, but you can do two things. No, I'm just going to stick with the one thing. So, if we just leave this one, oops, if we just leave that one, yeah, equaling, oh, we're adding two things. Well, when you add, it's the product, so natural log, e to the third multiplying by e to the fifth. Now, see here, we got the same base, right? So we just take one of these, and what will be the exponent? Well, multiplying, you have to add, right? So we're really going back to this. We are adding now. 3 plus 5 is 8. So natural log e to the 8th power. Okay? And now, two more things. You got a natural log here, and an e natural log here, and an e here. They're the same, so you can let these guys cancel, right? Or you can change this to a log base e, and this will cancel. Change this to a log base e, because this is the same thing as that, and e are the same, so they cancel, and let x equal 8. You can do either way. Ultimately, this is our answer. But now let's see if we put them in. 8, no, everything's fine. 8 to 3rd, that's all, right? Yeah. We plug it in, we're good. Yeah, perfectly fine. So this is the right answer. On my fifth example, I'm just going to do it very quick. Well, this one is a little bit tricky. Not tricky, but it requires a different type of thought. Okay, so the first part, it may look easy. It may look easy at first. x squared. Did I do that? Yes. It's the base. Log 2x, and this whole thing is squared. Okay, so don't be fooled. This right here is not the same as that. This here, just the x is squared. Here, the whole thing right here is squared. So 2 of these, basically. Okay, before I do anything, I'm not going to do anything to this, actually. I'm going to do this. It may look intimidating, but it's not. I'm going to first bring this 2 over here. Okay? Our exponent property. Now, you might be thinking, what do I do now? Well, what you can do, since you're solving, going to get everything on one side, bring this over here. So you get 0 here, and you get log 2x squared minus 2 log 2. And what can you do now? Well, do you notice something that each of these pieces have in common? Well, they have a log base 2x. Log base 2x. So what do you think we have to do? We can factor. Right? If we factor a log base 2x from each of these, we get, well, we have 2 of these guys, so we just took one of them. We are left with one more. Log base 2x minus, we factored out, we're left with 2. Okay? And now these are, we just set them to 0, right? To solve for x. Log base 2x equals 0, and this guy, log x minus 2 equals 0. Just going to continue right here. This one, we got log base 2x equals 0. Now we can change this to an exponential function. We're saying 2 to the 0th equals x. Well, 2 to the 0th, anything to the 0th power is 1. So our first value is 1. What about this? If I just move the 2 over here, we get log 2x equals 2. So here we're saying this guy to the this guy equals this guy. 2 squared, that's 4. So our answers are 4 and 1. Let's check if they are correct. If we plug in a 1, we're perfectly fine. 1 squared. And same thing, a 1 here, you're good. Nothing's negative. A 4, good. A 4, nothing negative. So great, both of these guys work. Okay? This has been solving logarithmic functions. I hope you understood what I did. I know it's a little bit odd and, a little bit weird the way logs work. But, yeah, a lot of mathematics can be strange at times. But, yeah, anyway, I'll see you in my next video. Thanks so much.